Hi everyone. So in question 2 here, we're given that a random variable y has this PDF. So it takes some unknown value k between when y is between -1 and 1, and it's 0 everywhere else. And in pass A, we're asked to find a valid value of k to make this a proper probability PDF. And so we know that f of y must satisfy two things. It must be always positive, or at least non-negative, and it must integrate to 1. So to find a in part 1, we're going to integrate this and find the value of k, which makes it 1. So we have the integral from -infinity up to infinity of f of y dy must equal 1. I'm going to solve for k. So that is equal to, outside of the interval -1 to 1, this is a fairly trivial function, it's 0, so let's split it up into the trivial bits and the non-trivial bits. So before -1, it's always 0. Between -1 and 1, it takes the value k. And then from 1 up to infinity again, it takes the value 0. Okay. So clearly, these are easily seen to be 0. And we're just left with the bit in the middle. Integrating that, we get k y evaluated at -1 and 1, which is equal to k 1 minus -1, or 2k. So we get that 2k has to equal 1, which of course means that k equals 1 over 2. Okay, so that's part A. For part B, we're asked to find the moment generating function of y. So we know that the moment generating function, which we denote by m of t, by definition, is given by the expectation of e to the t y of our random variable y. Okay. To compute this expectation, what we can actually do is just use, we don't do anything fancy with the PDF, we just have to integrate e to the ty against the PDF. So we'll get an integral from -1 to 1 of e to the power of t little y, and then our PDF, we found k to be a half before, so our PDF is just a half over the interval -1 to 1 dy. So we've just got to integrate this with respect to y. And remember, that means we divide by whatever's multiplying y. So that's actually t in this case. And then we evaluate from -1 to 1. Sorry, we should be more explicit, and maybe we'll say, to make it slightly clearer, we evaluate it from y equals -1 to y equals 1. So computing this, we got a 1 over 2t out the front. Then we'll have e to the t minus e to the -t. And that will be our moment generating function for y. This is reasonably what we'd expect, because we know for the uniform distribution that if we have a random variable that's uniform on -1 to 1, from A to B, then we know that the moment generating function is given by e to the bt minus e to the at over t b minus a. So that's for a uniform random variable on the interval ab. So it checks out.